Okay, from here on out, we're recording, and this is the first seminar of our spring 2012 series. Sorry we're getting started a little bit late, but I had some issues that I don't want to go into on the recording. So this talk today, this is Robert Dubois. He is basically I don't know if you call it the master teacher or the teacher of teachers or what at University of Houston. And I had an abstract up really quickly. You can see the abstract on the website, but actually let me show you guys his abstract while you're here. Outreach activities of the physics department, UHCL main campus include lectures, tours, one-day classes, workshops, research fellowships, teacher mentoring and training. I don't want to go into everything here, but you can tell from that all the fun stuff, all the stuff that really gets people interested in physics. And so he's going to talk about that, and then you guys will be able to finally answer the question again, why did you major in physics again? So Robert's going to talk about that, and then afterwards we'll have some time for you guys to ask him questions. Do you need a laser pointer or anything like that?
I've got one in my pocket if I need it. It's right here.
Okay.
And you can ask questions at any time.
Okay. And after that, after the presentation, then the people in the class, I'll talk to you guys, and we'll go over some classroom stuff. So
okay.
With that.
How long should I be talking? I could go for an hour and a half.
It's generally around an hour.
Okay, no, around an hour. Okay, these are the take-home messages of what I do with high school students, what I do. Okay, all right. Physics is non-intuitive. Okay, and physics is differentiating. I'm going to show you what I mean by that. This is very difficult, what I would normally be doing. I wouldn't be doing all this right now. Because you have to understand, I'm talking to high school students. Some of them are very high level, AP C, AP students or AP B, pre-AP, but sometimes I get into the regular physics also, and I go into chemistry classes too. And then I talk to as low as, first grade. That's immensely fun. But this is the deal, okay? Physics is differentiating and it's non-intuitive. Let me see. With these students, almost always, I have to have an opener. I have to get an attention getter, always. That fire piston is a very good one. Mixture down, the heat just shoots right up to the ignition point. And exactly the opposite happened when I was doing high school. I would have one of these whipped cream bombs, okay? And so I showed them the fire piston, and the opposite, that's where you're compressing, you're putting heat into the compressed mixture, and then the opposite is where you release pressure or you expand the gas, and the temperature just drops off the table. So I do an air cream thing where I release the pressure inside the bomb, and then take that container out and toss it into the class, and they can't handle it. They're tossing it around. It's like what do they call it? Carbon dioxide cold. It's really cold. So it really makes the point. And then we can talk also. The only reason it does that is because it works against the atmosphere. It puts the heat from, its heat into the atmosphere doing work. And if there were no atmosphere there, if it was a vacuum, it wouldn't happen. It's not doing any work. Okay. Okay. I do the bicycle wheel also. You've done that before, right? And I tell them how they thought this thing is so smart, so they're so agile that they can keep their balance on a bicycle, when in fact the wheel is actually helping them keep their balance. And I go through that, and then they tell me that, well, good is that? I go, well, whole universe is not spinning in rotation. Gee. All right, gyroscopes, you know, rockets aren't going to hit their target unless they're guided by a bicycle wheel. So, you know, I connect up with them. Okay, and then the two important things just for fun, just to get them all back and see how long it takes to finally realize them. Okay. Did I tell you I'm not actually a physicist? I'm a chemist. I have a whole long, full career with Dow Chemical research chemist and as a product developer and interacting with customers for 30 years. Guys, American companies aren't doing this very often anymore. Pensions are going the way of the wind. I am living the rest of my life on a pension for doing nothing. And I'm also right now collecting Social Security, and I'm on Medicare, and my wife is on Social Security, and starting probably this year, I'll be on teacher retirement. That is so freaking sweet. I come from a ghetto. This is like, you know, I have to pinch myself. Can it be this nice? Am I dreaming this? Well, actually, physicists would say probably you're dreaming. Okay. Okay. The next slide, let me see how we go through this here quickly. If we just do that. Okay. We have a quark, we call it the quark-net system about particle physics. It's international. There are about 60 sites, I think, in the U.S. Maybe not just, well, there are a lot of sites in the U.S. University of Houston and Rice have a joint site here. About 4 years ago, there was a competition throughout the United States for how many students? For like 5 teams of high school students, each team 3 students and 1 teacher from throughout the U.S. competing for a free all-expenses paid 1-week trip to CERN. Okay, where they were tasked with putting together a video. All right, one of the students, they weren't all physics people. One of the students was a science major, the other, or science person. Another one would be a video person, and another one would be a communicative type writing. Okay, they were putting together a video. They were interviewing Nobel laureates. They got a tour that even the close families of those who work there don't get. Because Pinsky, the chairman of our department, has an experiment in one of these detector assemblies. Okay? So he personally took us around. They were in awe the whole time, in awe. They put their videos together, and one team, as a matter of fact, on the streets of Geneva, they came across somebody standing on the corner, waiting for a bus. So they walked up to him and started interviewing him, and he was answering questions, back and forth. And then finally, one of them said, "Sir, could you please tell us your name?" They knew who it was. "Could you please tell us your name?" I said, "Oh, really?" And I said, "Yes, we need to have you tell us your name." Peter Higgs. You know Peter Higgs? Higgs what it calls? Yes, sir. It was him standing on the damn street corner waiting for a bus. And they interviewed him right there on the bus stop. Oh man, I had a great time. So you see what that detector, we have to see all this stuff. We're talking about like the diameters of these detector assemblies are on the order of about 50 meters or something. It's about 80 meters underground, 27 kilometers in circumference underground. There are about 4 major detector points, if I'm not mistaken. One of them is called Alice, and that's Pinsky's project with Alice. And this is a guy here standing on the gantry doing some kind of work on it. You want me to dim the lights a little bit? No, maybe we should. Huh? There's one bank we can drop, right? Yeah, it's better. Okay. So this is just kind of fun, just to show you what they were doing there. There's another one. That's Randy Rookty, one of the. You see the tubes? This is underground. Of course, there are straight sections and there are curved sections. And of course, you know the electric field causes the linear acceleration, and magnetic fields are superconducting magnets, and they do the curve business, right? Okay. Okay, cool, fine. Okay, these are the kinds of things we do on our campus. We do school visits, so I guess I'm going to go to your school, or your husband, your school. And we've done it before. We do a Saturday physics thing about two times a semester. We just did one on neutrinos with Feng Lao, gave it last Saturday. And now, at the end of February, we're going to do superconductivity with Paul Chu. That's February 25th to 29th. Let's see. We do cardboard boat races. I'm not sure. I don't think we're going to be doing it this year. It's really a logistics nightmare, but we were just tagging on. The physics department was tagging on, helping them during the event. But I use the boat regatta as a way to get into high schools to teach them about fluid dynamics and buoyancy. Boat stability and buoyancy. There's a lot to that, and what they don't know is really kind of surprising. But in case I've never used animations much in my teaching. There's one animation that I use for the boat stability thing out of Sweden. So a museum in Sweden, and it's called, you can get to it on the internet by typing in Vasa stability. They built a warship in the early 1600s, the most awesome firepower at the time, and it was King Gustavus Adolphus. This guy was a military nightmare for everybody else. He tore new orifices all over Germany and Sweden, so small compared to them. He's one of the top military commanders in history. And he wanted this ship to solidify Swedish power, all right, to make it a world power. Well, this was before Newton. And you know that before Newton, they built things out of experience. We don't see the failures much. But after several failures, they got it right, Well, this was a new ship with this massive firepower. And when they launched it, it turned over in the bay. It cost them the kind of equipment that we're talking about for the whole space program. I mean, it's an enormous cost in the training. They just went little, and they raised it up, and they have a wonderful animation that takes you through all of this stuff with fluid dynamics, buoyancy, boat stability. It's awesome. It involves torque. It involves rotation. Oh, it's awesome. They're doing this coming weekend, the Mars Global Competition. And what I do, the role I play is I do they're elementary school kids. So I do the elementary school kids. Like an hour and a half I have with them. And I do like physics and the magic of physics. So I'll do both, steel thing with water and fire, and I'll do stuff like, let me see. Well, I'll do birdie. Did you ever hear birdie on the clothesline? Birdie on the clothesline? This is very much fun for lay people. You get the two biggest groups in the group. With the elementary students, it would be the parents, like two football players, huge monsters. They hold the line, and they pull on the line until it's taut, tight as they can get it. And then I asked, the last time I did it was a little Daphne, 6 years old, come up, and I told Daphne, I asked him, Daphne, do you think he's stronger than you? And she said, yes. Do you think he is? Well, Daphne, suppose I told you that you're probably 10 times stronger and more than both of them put together. Really? Cute. But yes, Daphne, that's what I want to do. They're going to pull on this rope as hard as they can. They're going to try to stop you from moving this rope. All they want you to do, Daphne, is take your little pinky, wrap it around the rope, and pull down. See if they can stop you, Daphne. She goes up there, she does it. Then she do it again. I said, well, they weren't doing their best. Let's give them a chance, birdie on the clothesline. It's just trigonometry. the equation is there. And the whole idea is that the universe is directional. Force is directional. And it's like the way you apply it can give you a huge mechanical advantage. I won't go through it.
I think it's like both people have to pull infinitely on both sides.
Yes, sir. For a small force of only a very tiny deflection, their force has to be, the force could be almost infinitely small. Theirs would have to be infinitely large. It's an advantage, just a small deflection. Yeah, it's an awesome demonstration of the power of it. That's why I do it. All the kids look into that. I talk about now. This is your car in the ditch. I used to do that in high school. I take my SUV, park in the lot. We take a cable and winch, tie to the back of the bumper, tie the other end to a light pole. All right, with a winch on it, not to pull the car, just to keep the line taut. Okay, and then I have them march up one by one, grab the cable and pull like this, and they walk the car across the lot. Mechanical advantage. She pulls this far, the car moves that much. Her force is tiny, the force on the car is proportionately large. Really cool. And the students just go crazy over that. I have a lot of fun with it. Okay. All right. So right now we've just gotten a grant that's been funded starting February 1st, where we're partnering up with Pasadena District. It's got to be like a low level, what I want to say, like low income, we talked about area. Pasadena fits the bill. And we will be working with physics teachers to boost their level. Starting February 1st, we're starting that. And we'll be setting up a program of partners. They'll be partnering with each other. And we'll be doing a lot of mentoring with them. We'll have a workshop in the summer. And as time goes, we'll see whether we want to expand it, include more schools, and see how far we can go with it. That should be a lot of fun. With our CourtNet system, we give a master class in March time, where we invite about 45 high school students and teachers to analyze collision events from the CMS detector at CERN. So they get actual collision events, and they get the standard model, lecture, and then they're shown how you go about analyzing the events that they see, and then they look to see how good they are, and they're hooked in by video conference to 2 or 3 other sites in the country. And sometimes we could do Europe, except there's a time problem there, obviously. Okay, master class. We do workshops with students. We have student researchers and teacher research in the summer. We have constant ray detectors that we give to high schools on the wall that we work with. And let's see. Okay. I don't mean to get too hung up on that kind of stuff. Sometimes I do this too. This is the kind of thing that I was faced with when I first started out with Dow Chemical, a long time ago, ages. Okay. This is what they want. All right. Good team skills. They didn't used to have integrity and honesty. George does so well. Huh? Some of them still don't. Okay. Most companies have tacked that on recently. All right. Now, what I tell my students, the students I talk to, doesn't matter that they don't have any integrity and honesty, but you damn well better have. And it's good, and it's like Benjamin Franklin said, good ethics is good business. Period. It will work for you, even if it's scary. I've been through. Hey, listen, guys. I was a town councilor in Massachusetts I was elected 3 times for a town of about 40,000 people. All right? And I was facing down the mafia. This is in Massachusetts, an Italian town. I wasn't facing them down. I was very covert in how I went about defeating their intentions. All right? One day, and I never told my wife this until we moved to Texas. I wanted my car, the brakes weren't working. Now in Massachusetts, that's very important. It's not like Texas. You try it. You take off and drive, and right away you're on a hill. The brakes didn't work. I mean, right after, so I looked underneath, the line had been cut. I took it to the repair. I had it towed to be repaired. The guy looked at me and said, did you know your line's been cut? I mean, someone cut it. So I said, yeah. That was a good thing. I didn't tell my wife because she all scared and everything. But I felt comfortable with that, much more comfortable. Because guys, if they were bothering to cut my line, that meant that they weren't going to kill me. They wanted to kill me. It was done. Wow. I had a lot going on with me in Dow about that stuff too. It's very important. I won't bore you with all those stories. Just have it, okay? And something else I've discovered is the employers of the world want problem-solving skills, and generally they know the best way that they feel good about whether or not you have problem skills is how well you did in your physics courses. They actually use that. They don't know anything about you. So if you've done well in your physics, in demanding physics courses, they want you because they got problems to solve. As a matter of fact, when I was in the chemistry laboratory in New England, we would get applications in. We were all PhD chemists. We'd get applications for a new opening, and several of us would get together and say, well, listen, we're not trying to do all these applications. We've got a screen. We've got to use a screen. The screen we use, this is a chemistry laboratory. We would go to their high school and college transcripts and see what grades they got in physics in both places. If they couldn't manage a 3+, we just didn't look at the rest of it. We didn't have time to do that. And then we figured if they couldn't do problem solving well enough in physics, then maybe even if they're a chemist, maybe they can't solve the problems well enough, then we have to. So the idea with the high school students is that doing physics has some oomph with it, more than most. So let's see. You don't need to see this stuff. You want to know why it's on this list, right? Why are you in physics? Okay. Students who wish to differentiate themselves from other medical school, law school, business school, engineering school, teaching school applicants. I don't know if you're aware of that. Your physics degree means a lot. Okay? Should I show you what it means? This is kind of what happens with, what is it here? All of physics and career aspirations. My fields of study in physics bachelor's. Okay, bachelor's going up to graduate degrees. They have a bachelor's degree in physics. 64% of them go on in physics or astronomy. Others go there, and others go here. My brother-in-law is a cardiologist, a damn good one in Kentucky. He graduated with a physics degree and then went to medical school. Okay? That's unusual. Like if I look at the same deal for chemists, it don't look like that at all. It's chemistry, period. And this is the kind of employment that you get for a physics bachelor. All right? Let's take a look at it. All right? Computers, engineering, non-STEM, 32%. What are they doing? They're solving problems. Other technology, education. Okay. This is cool. You did the right thing for yourself, even though you don't want to know anything else. Even though you don't want to know anything else.
Yeah, thinking about somebody on a field, somebody mentioned things like journalism.
Okay.
Things that you wouldn't even begin to associate with.
Absolutely. You want to be a science writer? Look at the dopes that are out there. I would think that would command some kind of value to be a good science writer. Mm-hmm. Because there's so many dopes. All right. These are the MCAT scores in 2003 for going to medical school. You have to take this test. You have to score a certain level to get into medical school. All right. I already know. I looked it up. Johns Hopkins University requires that if you've got a bachelor's degree in biology, you must come with a 3.2 average. They will not accept anything. Excuse me, 3.6. 3.6. Okay? If you come to them with a physics degree, 3.2. What's harder? Right? But it's also more desired. And those who score high on the MCAT exam are not biology majors.
But most of the applicants are biology.
I understand, but most of them are dead in the water. I know. I taught lots of pre-meds. They died in my class. Miserable deaths, unless they took a good course of physics in high school. And that's what I stress when I go to the high school. I ask medical, how many are going to do medical? That's almost the best thing you could do for being desired and wanted, having a secure future. Now, you have to understand, you have to take a good level of physics, at least pre-AP. Do yourself a favor, do AP-B, all right? Because what you learn in college is AP-B, exactly the same. I taught AP-B in high school, and in college I taught the same damn course, all right? So those who took pre-AP at least, and AP-B, just sailed through my course, no problem. Okay, and these are the results, just to show you that this isn't just a fluke, 2003, this is 2009, latest, that's the same deal. Problem solving. You know, they get even if you're not taking much biology at all, you get problems to solve. There's a technique about it. I don't know that I could, well, no, actually, I tutored somebody who was having difficulty, a smart kid at St. Thomas High School, very smart kid. He was having his first test in physics was 77, freaking out. So I gave him 1 hour and a half session. He paid for it, his parents paid for it, but that's all he needed. And what I did was go through with him what you must do to solve a problem in physics. They don't realize, when they come into physics, they think it's like a math class or something, right? They think it's like chemistry, where you just have to do the moles and all that crap. You know, there is a technique, and that technique is applicable through life, with everything. This is the same deal with the law school. Okay? One of our undergraduates, physics, decided he would take the LSAT exam. His girlfriend was going to go to law school, majoring in the things, political science, and the things they do to go to law school. Okay? And she was laughing at him, you know, why do you want to do that? We haven't taken any of those courses. No, just to see. But why would you want to depress yourself like that? I mean, why would you? He scored higher than she did. Rest my case. I rest my freaking case. All he gets on the LSAT exam are all these manufactured situations of solving problems. You just use your skill that you've developed over 4 years, 3 years in college. Okay. Oh, this is, what is this? What is this? No, wait. Oh, you need to see this, okay? And I tell the students this. If you get a degree in physics in college, you're standing in the middle of a circle of several doors that are open to you to move through. You've got your bachelor's degree in physics. Now, what do you want to do with your life? Medical school will suck you up, and New York second. You know the Bernoulli effect? Your eardrums may break. It's like that fast. They show you the back door. Well, everybody else will line up here. You do the same thing in law school. You want to be a lawyer? Okay. Lawyers, they all know the same shit. Wait a minute. That's okay to stay here. You're going to mention Pinsky. They all know the same crap. How many of them have, like, technical skills? When I worked for Dow Chemical, periodically we'd get administrators coming down to the lab saying, could you please sign up and go to law school for us? We need lawyers, whether it's patent law or there's all kinds of law associated with chemical industry, believe me. But they beg you, listen, we will continue paying you your exorbitant salary. Your house we will hold for you in perpetuity. Nobody, no renting, no nothing. We pay the mortgage, we pay everything. We will get you a place anywhere in the world you want to go. You can have that. R&R, back and forth to home, all you want, all expenses paid. Just the only requirement is, I forget what it was. Maybe about 5 years you have to work for Dow, and then you're free if you want to be. We're not treating you on you can go. But they don't train lawyers to do that kind of thing in law school. They have to come over and train the ones who already have those degrees into law school. Computer programming, financial analyst. At the main campus, we have the guy, you know Macaulay? Guy, don't you know anything? This is the guy who wrote the textbook on the use of physics models for finance. Carl physics. Yes. Macaulay. Okay? He wrote the damn textbook. His students get jobs on Wall Street. I know they have a very bad reputation these days, but they get jobs on Wall Street for multi-hundreds of thousands of dollars a year. They're treated like damn Hindu gods. Nobody, before they use these models, they use like standard arithmetic that all the business types should do. And the accuracy of those models is only in the order of 50%. And my point is, just flip a damn coin, save yourself a lot of work. It ain't that much different. Flip a coin and do that. Right? The physics model gives you like 98% predictability. It's awesome. You should talk to that guy. He's like a model. He is a model. Okay, so you want to, they'll pay you in the business world. As a matter of fact, in any business, if you want to go to business school, you go in with a physics degree. What other business type in your new working environment will know anything about physics? Give me a break. And every time there's a technical issue that comes to the company, you're the one that's asking smart questions. They don't know anything. The others, the business school guys, what do they know about technology? And then they'll sit back and defer to you. They'll step back in the shadows. You're asking all the questions, and after it's all done, they'll put you and say, well, what do we do? What's your choice? Then you can say, well, we should give them money they ask for. We should give them none. It sucks. Or, let's give them this much, have them go to that step and see, and then reevaluate. Boy, does your value go, whoa. It's good to know a lot of different things, including psychology. I'll tell you why. This is worth you guys hearing. You know psychology? I use this all my life. Not all my life. Like later years. Okay? Everybody has a personal bubble. You know that, right? There's a certain space where if someone gets in it, it's like they go through a defense mechanism. They feel threatened. Okay? Shall we demonstrate it? Sure. Let's demonstrate it. Come on up. I'll do it with the teacher. I'll show you what I mean. We'll turn on the lights full. And I'll show you how I used it to my advantage. Okay. Stay right there. Just look at me and no eye contact and so on. Okay? Right? I already saw some eye twitching. Listen, don't feel bad. You can't help your personal space, huh? It's personal space. I come from an area on French-Canadian origin. We have no personal space. They have to stand on top of me to invade my personal space. The guys kiss each other, right? Friends and relatives. I had to like wash myself clean of those weird behaviors. Okay, touchy feely, everybody. Hey, I won't do it to you again. Huh? I won't do it again. You can't help it. You can change it. Once you know, you can change it. Boy, it takes a lot of work. That's like from babyhood. That's in you, period. And you have no choice. When I do that with the students, sometimes you'll see them start to lean back, they'll turn this way, they'll start blinking, and get a little red face. So you know where their bubble is. And the important thing about knowing that, you guys know enough, I can tell you the details. The important thing about knowing that is now you have a choice of how to deal with somebody's personal space. All right? You know that if you step into somebody's personal space, what does that say about your position relative to the other person? You're dominant. So if you want to do that, if that would serve your purpose, you already know. But you first have to find out what their bubbles are. You can work that out. I used to do that all the time. I used to figure out everybody's personal space. I knew when I wanted to, I could step into it. We had okay. So if you're stepped into somebody's personal space, they can't think of anything else. a genes level. Now, that can be dangerous. You don't want, and if it's intergender, you got other issues going on, so be careful with that, okay? But at least between men and men, I'm sure between women and women, but if you did it to a man, you may get the wrong response. Okay. We had our supervisor at Pasadena Memorial High School was one of the assistant principals was my supervisor. I reported to him. He was very martial, kind of like how you would see maybe a German group or something. An army, German army, very martial, very precise and so on. Very nice. I mean, meet that, all right? He would not distribute the books to us. Our students, we were going like it was a few weeks. The students hadn't had books yet. But I was begging with them, no, the computer is down, it's not working. I won't be distributing the books. So I had a responsibility, they're responsible for the books, so I have to enter into the system. And I said, I'll be responsible for it. No, we're not going to go ahead. You wouldn't have to for the whole school. The school was up in arms about it. Well, like 6 weeks by the time. Well, one of our physics teachers, I had computers, and one of our teachers had none. The IT department had a bunch of them that were out for them. They got new ones, so they had a bunch of them sitting there. So I went through channels asking, could we get some over to the other physics teacher? Nothing was happening. So I come from Dow Chemical, where part of my value was making things happen, not through channels. So I just went down there with a cart and got in the computers. And then the next day, my supervisor sent a message to the whole school. He didn't address it to me personally. He said that when you do stuff, you must go through channels and blah, blah, and he really offended. Never named me. And I was wondering, why is he moaning on everybody else? It was me. So that day, I used that. I knew his personal space was about like this. Okay? And he was standing in the middle of the lunchroom. I was there, and my other physics teacher. And I said, oh, okay, there he is, right there. All right, I'm going to get the books today. He said, how are you going to do that? But watch. I went around the periphery until I got to a point where he was standing, looking directly at me. Okay? So then no less that, I started walking towards him. And I stood right in his personal space. And he saw me coming, and he kind of like went, he was, and he saw me step into it. I know in his mind he was thinking that I was going to dress him down for beating me up like that on the but I didn't care. I had the computers with my kids. What do you know? I'm from New England. We don't care what people say about us. Give me a break. It's like what you do, right? So I didn't address that. I just stood there. I said, Mr. So-and-so, I need the computers. They should be about that big. It don't matter. Okay? I need the computers for my students today. Anyway, okay. And I stepped out. He got what he wanted, me out of the space, and I got what I wanted, my computers. That's worth telling you, isn't it? Find that for. Don't do it in New England. It's like this. No, it won't work. Okay. And as far as a teaching career, if you have a physics degree, you can teach high school just like that. That's what I do. When I retired, I went and taught physics. Top of the food chain, you can do almost anything you want in some cases. Like the principal that I worked for said to me, I told her I wanted to teach in that school, and she said to me, wow, it's not as though there are physics teachers standing on corners looking for jobs, looking for teaching jobs, that is. So she hired me, and she told me that their record, typically with people with second careers, it's 50-50, you never know. Either they're very, very good, or they suck bad. And so she never knows. She had me come on, she had no idea, but I was determined to teach in that school. And it worked out very well. She left me alone. I was top of the food chain. I didn't do any lesson plans ever. The whole 3 years I was there, everybody else moaned and groaned about turning in lesson plans. And so if you want to teach high school, that's it. That's the course you want to teach. College here. You can get a job almost anywhere. Okay, let's get out of this stuff. This won't do you any good. You'll just say, I came across this little quotation. It was from American Institute of Physics or something, and I couldn't locate it to reference it. It was just that they did some kind of survey, And a lot of students, who got like degrees in physics, well, you read it. It was interesting that a lot of students in the survey who were in some other field wished that they had started out in physics. Wished that if they had to do it over again, they would have done physics. You guys, I don't have to teach, I don't have to talk to you guys. You're doing the right thing. Interesting, huh? But I couldn't find the reference, so, you just have to trust me. I look trustworthy, right? Oh, you laugh, both of you. Okay. What I do with students is this, all right? They complain. Physics may be foundational. I give them all. It's the basic science, right? All others are actually specific areas of physics. They have no credibility. And mathematics is the basis of physics. Physics is actually nothing more than a storefront for a numbers operation. Are you guys old enough to know what that means? So I tell them, listen, guys, physics. I'm telling you a secret here. Okay, this is something you didn't know, and I'm telling you the truth. Physics is actually the easiest course you can take, because there are only 3 basic principles to learn for them. This is it. Okay? Period. Well, later on, it comes slowly. You notice I don't put conservation of momentum. That's right here. That's the 3rd law. When they take momentum, they take a whole different step. It's not, right? It's not. It's Newton redress. And so there are only 3 principles that they have to learn, just 3. And now that they know them, we talk about conservation of energy with the fire piston and a couple other things. And I do Newton. You have Newton's cradle? I think we do have that. Yeah, in the upper one. If you have a Newton's cradle, like a good sized one, you show them, you talk about conservation of energy, potential, kinetic energy, and all that stuff, but it starts to wind down. And you go, well, wait a minute, violating the law, right? What's going on here? So they go to the other thing, and they're kind of confused. Then I take a little piece of paper, white piece of paper, and I set it up against one of the balls. I pull back maybe 2 of them, let go, and when it hits the other ball, I pull the paper out, and it has a char mark. The paper is nothing but carbon in the water. Chemically extracts the water out of the charcoal right at that point of contact. Heat. That's where the degradation is going to. The balls are being heated. But right at that point of contact, in that instant, it's very intense. Cool. Good demonstration. And they go, I show them paper, blank paper, right? No, I do that. I go, what's there on paper? A black dot. Okay. And there are only 3 basic characteristics to the universe. All right? Everything except energy is directional. And we do birdie on the clothesline to show them the power of directionality. That's why they need to know trigonometry. Everything is directional. It's digital. Energy levels everywhere. And what I do is I toss something like this and I say, you think it, what do I say? Oh, let's say, what do they call it? 2-dimensional motion, or what is it? Projectile motion. They call it projectile motion. And it's nice continuous line, right? They say, yeah, it's a nice continuous. And I say, no! It's not! Actually, it's like, that's what? Very, very tiny. Very, very small. But I give them the word, and then I tell them, although you can't see it here, you can see it in atoms. You can see the digitality in atoms, correct? Going from one level to another, all right? And how it disappears from one and reappears in the other one with no existence in between, kind of. Like, what the hell's going on? It's digital. So I'm not spending a lot of time with you guys. I go through a lot of them, all right? And it's resonating wavy. And the way I get that was, again, in the atom, the electron, the electrostatic force versus the gravitational force is enormous. 10 to the 40 times, all right? That electron just slam right into the photon. That's the end of it. Become a neutron or something. But it doesn't. And it doesn't because the universe is digital. And the electron is actually kind of a wave. And apart, not really. You know, we only use. I asked them, I'm all just disoriented by you guys because you're not like that. One of the things I start with is I ask somebody to please give me a definition of physics, and then I get some good ones, and then I step back and I say, okay, this is my definition of physics. Physics is the study of interactions between matter and matter, between matter and energy, and between energy and energy. That's it, folks. So little to know. All right? And it is a system of models, both conceptual and mathematical, that are built in order to predict behavior, not because the models themselves are necessary, but because we have no way of handling it without a model, because it's so non-intuitive. Okay? And I'll hit that in a couple spots here. Okay. It's not hard. It just doesn't make freaking sense. Okay? You know that already. It's non-intuitive. It doesn't respond to the normal student approach. Get this. You probably know this already, right? A lot of students, and I've taught in high school and I've seen in college, a lot of students get very adept at taking multiple choice tests. They can know almost what and do fairly reasonably well. And I could see them when I was teaching in high school. It was great. They'd be sauntering in the class. Okay, here's another course that we're going to knock over. They come sauntering in. They're going to apply their techniques. No studying, hardly any, and then they're going to pass the course. Okay, so they do the normal thing. What they do is they look at the question, see what the question's kind of looking for, and then they look at the answers and see, well, number A makes no sense at all. Okay, here's that one. And B, well, that one's possible, but it's not very likely. It's kind of weird. And C, that's probably good. And D, there's no connection with the question. It doesn't make any sense at all. So you get rid of A and D, and now I've got your choices like 50-50, and C, you think you saw something in the textbook that could have reminded you, or you heard something in class at one point. So it makes sense because it was connected up with the topic at hand. C, it's not really a 50-50 choice, it's an informed choice. So you end up actually getting credit for it. It's hardly that much of a choice. And squat. Now, first of all, when I give multiple choice, I don't, no credit for answering the question right. They have to show their work, always. I do that always. Never. No credit. I never answered. No credit. Nothing. I don't care. Okay. But, so, they'll come in, and the right answer was the one that made no sense. That was weird. What's that all the time? So they get their test back and they got a 10. They're used to getting 60 anyway. It kind of like throws them off kilter. They have no idea what's going on here. The traditional approaches don't work. Okay? Because physics is not intuitive. What they actually do, there are only like 3 principles and 3 basic characteristics of the universe. But you actually have to know the explanation of how the universe works pretty well, right? For example, when I do the student, I go, oh, that hurts. Okay, that's hard. That tabletop is hard. And the universe looks at me and says, that's not hard. That's not what's hard. I said the tabletop, And the universe looks at me and says, nothing there. I go, what? That hurt? I don't care. It just doesn't care what I think or feel, because it knows that my experience of the universe is grossly flawed. Okay? There's nothing there. You know the idea, right? It's a hydrogen atom. If your fist is about this size, it represents a photon. How far away the electron is? Huh? No. That's good. That's one big. That's good. It's about 6 football fields away. Okay. 3/4 of a mile or something like that. So then the next question, so you start thinking of something like that. So, what's in between?
Nothing.
Nothing, that's what they say. They say nothing, nothing. 99.99% empty space. The universe knows that. Trouble is, in physics, there's no such thing as your concept of nothing. Not knowledge, right? For example, right here, sitting right here, you think, you see my hand, not exactly anything, and everything's fun. Well, space of my hand right now, every second, a trillion phenols zinging through it. That's pretty awesome in my mind. Per second, on a regular day. That's not even like sudden burst. And so we sit here and we think, actually we sit here and we think, well, we're just sitting out here not moving. So I asked them about how fast I'm moving. Somebody said 1 or 2 miles an hour. And I said, well, that's a pretty good guess. No, usually I'll say 1 or 2. 1 or 2 what? It's like, that ain't physics. No, don't give me a damn number. Tell me miles per second. I prefer that. So then they give me miles per hour or something. And I say, suppose I tell you I'm actually moving 750 miles an hour. Would you believe me?
I think it's all relative, right? It's from your perspective.
Well, what? I'm telling you I'm going 750 miles an hour. Am I right or wrong?
You're right in the perspective of
What perspective?
the Earth is rotating, so yeah, you're traveling. But right now,
At the latitude of Texas, it's about 750 miles an hour. I'd be equating for 1,000, right? 25,000 miles to come from 24 hours in a day, it's about 1,000 miles an hour. Right? So we're talking words magnitude. Now here it's about 750. Then I ask them, how fast am I moving then at the poles?
all about your record.
24 hours, you only go like this. Yeah, that's fun with it, that's fun. Okay. But then I say, suppose I'm telling you I'm actually going 10,000 miles. But I'm walking, the earth is going around the sun, and then the sun is going around in the galaxy, and the galaxy outside is well, it depends upon with reference to what? What you said. Okay? In physics, right, position and velocity are referenced. There's no such thing as absolute. You have to have a frame of reference. That's why they force you when you do these problems. You have a frame of reference and a point, and that's the center of the universe. And this is the way it's laid out. Okay? Not because it's intrinsically that way, just because you're God. You can make it that way.
It makes the problem easier.
Yes. So you're moving because relative to me, and I'm not moving because I decided it. Cool. Powerful. Okay. So, definition of physics. Oh, okay. So I point out again to them that in order to do well in physics, so not that much to learn, but you have to be able to explain things that are happening very well. You have to get out of your non-intuitive mind, and you have to get precise. You have to follow the definition. It's like a religion. It's the Bible. Okay? This is the definition of that, and that's the definition of this. And I don't care what you think. You go by that definition, or you will end up in the wrong place. Period. That's the way physics is. So you don't have a lot of wiggle room in physics. That's why it's hard. You guys they never faced anything like that. It's all been biology and chemistry. What the hell's that? I don't know. Okay. Let's see. Oh, this is yeah. Okay. What I do is I tell them, and the nothingness that we're talking about, actually, the universe is a throbbing, and full of neutrinos and God knows what. All kinds of quantum weird effects. And time and space, nothing is not a relevant discussion in physics. There's no existence. Nothing is nothing in physics. Okay. Just because you don't see it, okay? The only reason you think that's hard is because because of your delusion gene, I tell you. Okay? Those people who knew the truth that there's nothing here, hit their head against it and died, did not pass on the truth gene. Only those who were convinced there's something there pass on the delusion gene. You're stuck with it. I love they eat that stuff up. It's really good. Did you guys ever see this about Hall thing? Let's get your education. How do I want to do this? Tell you what. Can I have a volunteer to catch this when I drop it? Okay. And I've got cords in here, right? They're on a coat hanger. Don't know. You let go, it'll pop up. I knew it. You guys just keep your eyes waiting. I thought he's going to come on up. Of course you go. Give me a break. Okay. So, sit down. Yep, sit down. Because everybody has to see what happens, okay? When I drop this, of course, you know what's going to happen to the cords, right? Huh? Catch it. Well, any way you want to protect yourself. Okay? What do you think is going to happen with the cords? You're not going to come on. Is that right? All right? You want to try it? Okay, I'll release them both at the same time. I'll go 1, 2, 3, go. So you know I get this. 1, 2, 3, go. Cool! It does that every time. You know what? I even did this with my high school students. We'd go outside and we made projectile motion of it, where I would toss it and I would get good at it after a while where we wouldn't spin. It would just go up to the top, then back down and get caught by the other person. And the whole damn way, once you release the normal force, the only force acting is the force due to gravity of the air. That's all. The only reason you have buoyancy is in a case where you are prevented from being in free fall by normal force, right? The only reason buoyancy is actually the liquid version of the normal force. The normal force of my hand and the container against the water is transmitted to the water, and it provides a low force. It transmits that low force to the point. Once you get rid of the normal force of gravity is operating. Now I can test you guys. This is a test. Now I can test you guys. Okay. You know what G is, right? Little g in gravity. You know little g? Yes, we do.
Oh, little G?
Little G. 21? Not the universal, the little g. Huh?
21 meters per second squared.
The second square? Is that what? Is that an acceleration?
Yep.
Yeah, 9.8 meters per second square. I'm here to tell you that that's a flawed interpretation, only on the Earth. No. You're on the wrong track. So totally wrong. I can't even talk to you about it. Listen carefully. Okay? Watch. I do this with high school students too. They love me. They think this is fun. Okay. All right. You've done electrostatics, and you have a charge here, some kind of charge, right? Q. Like studied right. Q. I don't know. No, it's wrong. Q. All right. And you've got a field, correct? All right. At various points out there. Now the field is due to this charge. Let's say it's plus Q, and the field strength is due to that at different points. And the field strength is, let me see, just like gravity, okay? Where now you've got a field, you've got the mass of this here has created the field that something else is in, say at this point. And there's a field strength associated with that mass. There's also a field strength associated with this point here as well, right? That this mass is feeling. But that's not my point right now, okay? If you look at the equation the gravitational force. It would be, mass, say, of the Earth, mass of U, okay, over the distance between you and the Earth center squared, right? Okay? It turns out now that the field strength for the mass of the Earth is this. Little g, correct? Okay? These units, everybody is so hooked up on meters per second squared. Well, you could say meters per second squared, but it ain't really. It's newtons per kilogram field strength. Newtons per kilogram of that. Just like in a charge, the field strength of the charge is newtons per coulomb of charge on this charge here. Correct? That is a field strength. It is not an acceleration. And the proof of it is everything falls at that so-called acceleration. Everything feels that field strength. And it's mediated by the mass of the thing that's feeling the field strength. Doesn't that change your idea about the little g? It's been stuck in your head as an acceleration, only because the units cancel down to that. It's actually a field strength, newtons per kilogram, correct? Kilogram meters per second squared, you end up with meters per second squared inadvertently. And if you measure grades, that's what you end up with. Cool, huh? Okay? Everything in here feels that field strength. The water container, the quartz, the air inside, all of that fall according to that field strength, G. There's no need, there's no pressure differential between any of them. None of them are pushing each other down. They're all being pushed down by the time, by the space-time falling into the Earth. They're moving in accord with that. They're in free fall, only, we call it free fall, because it's only that force of gravity that's being felt by all of that stuff, and it's actually a field strength. They're all falling at that field strength, and that would be 9.81 meters per second squared. It's got those units. Too bad, because it's confusing everybody. Now, knowing that, yeah. Okay. Knowing that, then you ought to be able to answer a question. Let me see. I showed it to you too soon. This is a candle. What's this?
Candle and atmosphere.
You've seen it before, right?
Microgravity.
Well, you call it microgravity. I don't really compete with that. Okay? This is really in free fall. It's in free fall. The only force acting on anything in here is the Earth's mass, the field strength of the Earth. Okay? So all of this, the shape of this flame here is a direct result of being prevented from being in free fall by a normal force. That makes everything happen here. Buoyancy, convection, all that stuff happens out of the fact that this is prevented from being in free fall by a normal force. You take the normal force out, and this is what you get. If you're on an elevator with a candle, okay, you got air in there, you say, okay, cut the cable. That's what it looks like. So the shape is a sphere. Only it's not a sphere here because the candle's in the way. Here's the way. The candle is in the way. But it's also blue. And I asked them, why should that be blue? And you know why, right? What makes it blue? Yes. I'll leave it to you guys. Well, the characteristic that it has. So it's a sphere rather than a tongue. They refer to flames as tongues of flame for obvious reasons. Okay? And it's blue as opposed to yellow. What does that tell you about that blue flame?
It's hotter.
Thank you. I'm getting scared. Hotter. A hotter flame. What other characteristic can you see? It's harder to see. It's dimmer. It's dimmer because it's oxygen starved. Okay? The oxygen has a hard time getting through. There's no convection. See here, the heat is being taken away by convection currents. The heat is being taken away by the air. So it doesn't have a chance to burn as hot as it could because the heat is being taken away. Here, no heat is being taken away, so it's damn hot in there. But it's dim because there aren't that many reactions going on in there as there are here because it's oxygen starved. The only way oxygen can get in there is by, what do they call it, the normal motions of atoms and molecules. What do they call that? Diffusion. That's all. So oxygen can only get in by diffusion, and the reaction products can only get out by diffusion, just by random motion. Isn't that neat? I found it takes a while. I was showing this stuff in a bottle and this to physics graduates and even professors at U of H. It takes a few minutes to come to what's going on because you suffer. We all suffer from the delusion gene. This don't make sense. And that's why physics is hard, because it does make sense if you stick by the rules. If you stick with the field, rather, the field strength, if you do those things, then you got a knot. Correct? Okay. You can see how kids really love this. I just have a field day with them. You know what I used to do? I did it in high school, not a problem here, but I did it like the first year I was teaching like a couple hundred students in the introductory to physics, just algebra. They didn't trust me with calculus. Probably right, so I forgot it all. But the first couple of days, I would have like some stupid prizes. I asked a question from the institute, like prize, I get it, problems. So after 2 or 3 days of doing that, I said, all right, today, you guys have been getting prizes for getting the right answer. Now we're going to up the ante here. You will get a prize for the right answer, but if you have the wrong answer, you will get a consequence. So we started out with a couple prizes out there, and then somebody answers the question improperly, and I pull out a Nerf. It's a Nerf rocket. I don't have it anymore. It's broken. It's so beautiful. Not a moving part. It's just you just squeeze the handle, and it pops out like a rocket. The whole class is like a wave. I went, I shouldn't do this anymore. I might just make a heart condition. I don't think I should do this anymore. Oh. Teaching is fun. Okay. I've got this up here for a purpose. This is to address the idea of differentiation. I came across a book written by Charles Murray several years ago in Barnes & Noble, about this thick. I know Charles Murray. He and I don't agree hardly at all on politics. He worked with the American Heritage Institute or something like that. And you can tell by looking at me, I don't hang out there. But I know Charles Murray's work. Is highly competent in his treatment of data and in his selection of data. Highly technically competent. Okay? Half of his book is about his data treatment and selection. He had a thesis that his thesis to begin with was that the great human accomplishments of human beings are correlated or happen with form of government, freedom. Okay? Great human accomplishments, free government. Well, when he did the work, what he did was he took 2,000 of the greatest technical people from 500 BC to 1950, and he took 2,000 of the greatest accomplishers in the arts, like music and art and other things. Okay. And when you go through the list, I looked at the physics and chemistry list. We got them all. He's very good. And I know music and I know art somewhat. And I looked at them. Yeah, he's got all the big ones. Then he took all of these 2,000 people and placed the dots on the map, not where they did their work, but where they were educated, your age or younger. And then he saw there was no correlation with population. There were spots, dead spots, in the globe, centers of excellence. Yes. No correlation with population. no correlation with formal governance. He found the correlation. The correlation was between human accomplishment and the attitude of whatever government there was towards science and the arts. For example, Louis XIV was despotic as they cut the son king, yet he loved the arts and the sciences. And word was you could do anything you want, you could criticize the government, anything you want, it was okay with him, just be, they're free to do whatever you want. All I ask you is not to call the king shit. That's all I have to do is not call him that, something like that. So they had a lot of freedom, and they flowered because of it. So it was the attitude of the government. And he found that there were centers of excellence, and that's not surprising. What happens, what he feels happens is you have, when you have highly performing individuals in a certain field, it grows on itself. The standard for performance goes up in that area. Okay? So here, I'm showing you the United States from 1900 to 1950. Arts and sciences. Got a hint here. There's a message here. Okay? I come from this area. Right there. When I lived there, I thought the standards for performance in the academics were uniform throughout the country. I didn't realize that the standards that I was living under were not uniform through the country. They were specific to our area. They have very, very much less regard for sports than we do in high schools and college. They don't follow it like we do. They don't. Extracurricular activity in the public schools was after school. Here, when I taught in high school, they would pull out kids at random times, all the time, out of my class, because for music or art, or choir or football or whatever, they'd be pulling them out all the time. Never happened in Massachusetts, and a lot of them in the States. Okay? And they pay their teachers. They require master's degrees in the field that they're teaching, and they pay them very good salaries. And they're highly competent. Okay? So when I moved out of there, I was like, whoa, what's going on here? Okay? The levels of excellence up there, or up here, and here, like that. Now, Texas has done a good thing. They've adopted some very severe, hard standards, very top standards in their high schools and schools. The problem is that they're not putting the money behind it. That's a problem. But I won't go there. Now, usually this depresses my high school students when they see this. And I tell them, not too worried. See, this gap, you can overcome this gap because they aren't aware of the power of differentiation. I'm here to tell you there's huge power in differentiation. You can make up for that gap by differentiating yourself. For example, you want to be a lawyer, get a physics degree. Want to go into business? Get a technical degree from type 2. Learn a language or two. The fact that I know German and French gave me a career you wouldn't believe at Dow Chemical. I led the way in starting projects with European companies for Dow Chemical. Dow's experience, like most American companies, when they start trying to do something with a European company, they have to go through a long period of showing that they have the capability to work with them. They have very low regard for education. And I would walk in and I would know I could speak German and French, and my knowledge of history, to my point, differentiation means broad knowledge, reading, filling yourself up with useless information. I am full of useless information. I could talk to you here like 6-7 hours easily with all useless information in my body. But it helps me. I would go into these European countries, in their local area. I would know their history, going back a long time, their culture. We were entertaining some Norwegians in San Antonio, the Riverwalk, the Marriott on the Riverwalk. And it was after the business was done, we were in the restaurant late at night, drinking, having Mary. They must have been They must have done like 15, 20 of the Norwegians, only a few of us do now. And at one point, what comes up with Norwegian? What topic can just answer in just normal conversation do you think would come up with Norwegian? What are they about? Please. Vikings! They're eating, drinking, being merry. Of course, they're going to talk Vikings. And they did. They started talking Vikings. And at one point, I just go out there, I said, oh, yeah. The Vikings had a very hard time in America with the Australians. They stopped cold. 15 to 20 of them just looked at me, quiet. And their leader was an aristocrat guy. He owned a company, but he was also like he had one, boots and whatever. And he looked, they all then looked. It's the point. The Norwegians are public people. The Swedes are very reserved. The Norwegians are all over. Well, they just looked at it. And then they looked back at their leader, and he was looking down his nose under his glasses on. And he said, how did you know that? I said, you mean Australian? He said, yes. I said, just for a general meaning. The words, their words are American Indians in Sweden, and it means the dirty ones. For a general reason. Got it. Don't sell yourself short. Don't go out in the world and compete with them. Differentiate yourself. Get some knowledge in your freaking head. Or a differentiated career. No, it's not too late to do that. You had me. No. So I point out to the high school students, very important for them to know this crap. Okay? You can make up for that. Now, times change. This is 1950. Things are changing. I know that. Okay? It doesn't look like that anymore. I'm waiting for a sequel. The problem is that you get all this information from biographical and encyclopedic sources. People have to be dead before you put down a human accomplisher. So probably right now, he could probably extend it by another 25 years if he decided to do that. But it is changing. Cool, huh? The same thing for Europe, different time spans, and you can see centers of excellence. You can see it, right? And during the Renaissance, it was Florence. You know, Naples was always a large city, and they never were a center of excellence. Never. Oh, well, let me see. This is just about medical careers. I go through with the students about how if you don't want to be a medical doctor, go to medical school, you can have a very satisfactory career in the medical sciences with just a 2-year college. And a 4-year college won't do you any better. That's the only career of this type. You go and look at all the other technical fields, computers and technical stuff of any type, and you'll find that 4 years of college gives you a bonus in salary as opposed to 2 years. So if you're just interested in getting out fast, you're not going to get hurt by your pay. Something they should know. They can do it. I mean, there's no reason why they shouldn't, but this is just, blah. I never get to this, you know. This is Arthur Wegline. He's the he's the oil physics guy in our department. And this guy gets all those big oil companies are his clients, and I think he has a total of about 25, 27 oil companies as his clients. And I tell you, it's as though those companies drive up with dump trucks full of dollar bills and drop it right at his door, and they don't care about any accounting. His people get great jobs. I tell the students in high school, oil and natural gas recovery is a physics problem. You know, if you want to be out in the field just cracking rocks and so on, that's geology. But they'll often hire a physicist, and the physicist goes to them and says, well, I've never had any geology. The oil company says, well, I'm interested in geology. We'll teach you all you need to know about rocks right here. Something like that. We'll teach you all you need to know about rocks. You probably won't need to know much.
You can learn the physics, geology will be free.
Absolutely. Absolutely. Is there anything else here? This is all stuff. Okay. I rest my case. Did I make my point that physics is non-intuitive and physics is differentiating? Boy, you made the right choice. I decided to be a chemist. But broaden your knowledge. Make it deep and strong. I retired from Dow Chemical. Full retirement is great. And I spent the next 3 years doing something I had always wanted to do all my life. I always loved history, and there was a certain type of history that I really wanted to get into deep, and that is military and national strategy. Not the narratives, not battle narratives, but the strategies. Okay? So I knew what the Bible was. The Bible is from Paul is on war. Let's say on staff during the Napoleonic Wars. And he wrote this book, but I knew I couldn't read. I did not try to read that book first. I had to read around it first. I knew that. So I read around it, and then I read the book, and it was like, so beautiful. That's required reading in business college on war. The strategy is the same. The reason I didn't read it is because it was written in German, and he died before he finished it. There was a very, very rough draft form. Can you imagine what that's like? All the pieces were tied up together. It was a mess. To pick that up and start reading it that way, you won't get it. You won't get the point. You won't get what's going on. And as a matter of fact, a lot of people don't get it. When you see military people, oftentimes I'll see military people being to be top brass or something, and right away, he didn't get it. He didn't understand the point. He didn't understand. He didn't get it. But a lot of them do. So I did that for 3 years. One of the top, let's see, just a quick question again. In the Civil War, there are some good generals and bad generals, all right? Which general do you think is the most highly regarded, the best general in both sides? Pardon?
Robert E. Lee.
Anybody else? Anybody else?
Stonewall Jackson.
Anybody else? Ulysses S. Grant is rated by all of the international war colleges as one of the top 5 to 10 in all of history. In company with Alexander the Great, Belisarius, if you don't know who that is, Julius Caesar, Genghis Khan. Yeah, most people don't, and I know why. This guy was awesome. He conquered in areas the size of Western Europe, in undeveloped countries. Napoleon marched around, nice roads, lots of villages and towns, a lot of food. Okay? There were every general in the war, what they just salivate for just once is to have a situation where they have gotten the enemy in a position where the enemy has no choice but to surrender or attack and die. Okay? That happens occasionally, and once in a whole war is awesome. And that general is remembered in history. In the Civil War, it happened only 3 times. No other general did this. 3 times. He did it at Fort Henry and Donaldson. He did it at Vicksburg. He did it at Manassas. 3 times. And he came close at Chattanooga. And when Kentucky was, right at the start of the war, Kentucky was a neutral state. And the rule was, Kentuckians said, we're going to stay neutral. In essence, the first one who attacks or crosses our borders are enemy. So, the second commander stepped over the line to Columbus, Kentucky, because he felt it was such a bastion on the Mississippi River. And he did that. And the president of the Confederacy didn't remand anymore. let it stand. Shouldn't be ready anymore. You let it stand. And as soon as that happened, Grant was at Cairo, Illinois, and he marshaled all of his forces to immediately move on Paducah, Kentucky. Paducah, Kentucky, and the next town over. Both of them are the affluent of Tennessee River and the Cumberland. The Tennessee especially goes deep into the south, right into Alabama. He understood the importance of that. He got those two towns, which he captured. He sent a note to his commander, Halleck was the name, and he said, I am on my way to Paducah, Kentucky. If that is not agreeable to you, send a message, tell me to stop. Knowing full well he wouldn't be able to get to him. He just went on his own reconnaissance. He captured the place, immediately got gunboats together, and it took Donaldson and Henry. They captured an army, at that time, 14,000 men in Fort Donaldson. And what happened is they tried to get out of Fort Donaldson. They attacked one night, on one side to get out towards the south, and his Grant's generals panicked. And Grant was interrogating about it. He was someplace else. He came in interrogating about it. And the Confederates had knapsacks on their back. Oh, they're trying to escape. All right. Well, they just barely held up. So he immediately ordered the general on the other end of the line to attack full force. There was hardly anybody there to stop him. And the whole place collapsed, surrendered. He was after them. And the world knows that. And Robert E. Lee, by the way, lost many battles, and he lost the war. And he suffered more deaths and casualties than any other commander in the whole war. Stonewall Jackson, if he had lived, might have been something. His plan would have caused the Union a lot of heartaches, but they were in a more rigid system themselves with their aristocracy. You couldn't move up. Even with your merit, there was a limitation. Oh, cool, huh? That surprised me. I thought that was cool. Is that nice information or what? Oh, well. Okay, any questions? I'm all done. Yeah. Questions?
Okay, well, let's thank our first speaker of the semester.
Pleasure. Even though you're all attention seekers.
Let me stop.
I only had to kick, in the 4 years that I've been doing this at school, I've only had to kick students out of the class